everyone in the session, and let me introduce first myself. I am Abdul Rahman, a senior software architect of a fintech and IoT and M2M, and also a student of MSc Data Analytics and Technology at Bolton. Uh, First, let me introduce Dr. Celestine, fellow Higher Education Academy UK, and distinguished speaker ACM, senior member IEEE, visiting professor, Coal City, University, Nigeria, and senior lecturer and research coordinator, School of Creative Technology, University of Bolton, United Kingdom. and thank you, Mr. Mohammad M. Alani, to be my guest at the series November to Remember series of creative technology advancement talk on business literacy and employable skills and research method. Our organizers are School of Creative Technologies, University of Bolton, UK. Our guest, Mr. Mohammad M. Alani, a professor of cybersecurity at School of Information Technology Administration and Security, Seneca College of Applied Arts and Technology, Toronto, Canada. Now I will hand over to Mr. Shahzeb Khan for the brief introduction of our guest.
Thank you, Abdul Rahman. Hello, everyone. I am very glad to welcome all of you to our November to Remember series, where we are trying to help people with employment literacy so that people could be more productive, could go out in the world and could achieve their dreams. I would like to thank Dr. Celestine for setting this up and our School of Creative Technologies. Now I would like to introduce our guest. I would like to give him a warm welcome. Mr. Mohammad M. Alani. Mr. Mohammad M. Alani holds a PhD in computer engineering with specialization in network security. He has worked as a professor and a cybersecurity expert in many countries around the world. His experience includes serving as a VP of Academic Affairs in United Arab Emirates, network security consultants in Middle East, and cybersecurity program manager in Toronto, Canada. He currently works as a cybersecurity professor at Seneca College, Toronto, Canada. He has authored 4 books in different areas of networking and cybersecurity, along with many research papers in highly ranked journals. He also holds many industrial certifications such as Security Plus, Cybersecurity Analyst Plus, Azure Data Science Associate, CompTIA, and many more. I would like to welcome him and thank you very much for being here.
Thank you very much for this great introduction. I really appreciate it. And it's my pleasure to be here today and speak to this lovely audience. And thank you, Dr. Celestine, for the gracious invitation. Thank you very much.
You're welcome.
Okay, so should we go ahead?
Oh, yes, you are in charge now.
Okay, great. So, yeah, today we are, we'll try to cover a lot of bases that would span from forensic analysis and protecting the organization to how forensic analysis fits into the incident response process and how we can help as forensic analysts in avoiding larger problems in organizations. The agenda for what we will talk about, you can see it's a little bit long. Hopefully we will have time to do a short demo about forensic analysis, and we will take a look at some malware analysis on the way. I'm gonna skip the introduction. After the great introduction that was already made, I'm not gonna add to that anymore. So let's ask the first question. What is forensic investigation? And how does it fit within an organization that is trying to protect its assets from malicious actors? In general, the main job of the forensic investigation is to help the organization collect and analyze data. data that is basically evidence that we can use in prosecution of a crime. So the two main things that we want to achieve with forensic investigation are basically trying to figure out what exactly happened so that we can prevent it from happening. And the second is to provide evidence in a way that is legally acceptable. If we need to report an incident to the authorities, if we need to provide, the court of law with a detailed explanation of what happened, evidence needs to be handled in a certain way that we cannot just, randomly handle any data and just send it via email to the court. It wouldn't work this way. So forensic evaluations proceed with the assumption that the data collected will be used as evidence in court, which means that we need to collect data and maintain this data, maintain the integrity of this data in certain ways that would be admissible in court. Moving on to the role of computer forensics and incident response. How does computer forensics fit into the bigger picture of incident response? Computer forensics would help us in identifying and gathering evidence. And one important thing that forensic investigations focus on is trying to figure out what can be considered as evidence. Because when breaches happen, we generally don't know at the beginning, of course, without the proper investigation, we don't know what happened. So we need to collect initial information and then build a plan of investigation afterwards to be able to identify what evidence do we need to gather. The second role is to identify the root cause and the impact of the incident. We need to identify what exactly went wrong. And that is one of the most important outputs of the computer forensics investigation, because it would help us in preventing this from happening again. The third role is to extract, process, and interpret the evidence so that we can make useful decisions based on the evidence that we have collected. And number four is to protect the organization from similar attacks, and that is highly based on collecting the right evidence and identifying root causes properly. And of course, the eventual benefit would be minimizing the loss to the organization through doing all of these things. Forensic investigation usually has three general steps that we can think about. The first is acquisition of evidences, and then inspecting these evidences, and then reporting. So if you notice here, as a forensic investigator, it's not your job to fix the problem. Your job is to do the proper diagnostics to find out exactly what happened. And you can give recommendations. You can say that maybe adding a firewall here would fix this issue, maybe adding an intrusion detection system here, maybe employing some advanced machine learning techniques would help here. But the idea is that forensic investigation does not solve the problem. It focuses on acquiring the evidence, inspecting the evidence with highest possible details, and then reporting to our managers or to the institution what exactly happened and how, give like general recommendations on what can be done without actually fixing the problem. And that's why we think of forensic investigation as one piece within the puzzle of incident response, because the general umbrella of incident response focuses on the whole process, starting from detecting an incident, investigating the incident, finding remedial actions and doing the remedial actions, and then focusing on lessons learned from that incident. So forensic investigation fits as one piece in that bigger puzzle of of incident response. So what types of evidences do we want to collect? The actual categorization of evidences, as we will see, it's actually two different types of categorization. The first one is based on where do we collect the information. There are host-based evidences, which is basically the evidence gathered from the compromised system, such as logs, records, network connections, date and time of the system, the version of the operating system. All of this is considered host-based evidence, and all of it is important. So if you're using a Windows machine, just move on to
what the fuck you concept.
If you move on to your settings, and then, well, not necessarily settings, you can just go ahead to start and search for something called Event Viewer. Okay, take a look at the Event Viewer on your Windows 10 machine, just to have a quick idea. Let me reshare the screen with you to take a look at the Event Viewer. You can see within these system logs that we have a lot of logs. Although this is not a server computer, this is a client computer, but we actually have a lot of information, a lot of logs that are being generated as we use our computer. Every time you log in, every time you type in the wrong password or the right password, every time your system loads a driver, all of these things are being actually logged in your computer. So in principle, when we think of evidence, I don't only think about taking a copy of the hard disk or capturing, for example, memory content, but I think about all of these different things. Even the particular version of Windows that you're using, or any other operating system, the particular version is actually part of the evidence, because there are versions that have, for example, certain vulnerabilities that are known vulnerabilities, and because our system administrator didn't patch them properly, then that would definitely be considered part of the evidence and can be used by the attackers. So the amount of information that we can be collected from the host is a lot. In addition to evidences collected from the host, we have also evidences that are collected from the network. Information gathered from network resources, such as intrusion detection systems, logs, router logs, firewall logs, and so on. So you can see that we have many sources of information that are available on the network. When we have a firewall at the border of the network, then the firewall is getting a lot of incoming traffic. It's using its own access control list to block some traffic and allow some traffic. And then eventually all of these events that are happening at the router can be logged. And this information can all be collected and aggregated at what we call a SIEM software that can help us as part of evidence. Why is network-based evidence important? Because it is very much possible that an attacker can breach your system, and then part of their process, they remove the evidences from the host computer. So they can go over your log files, for example, your event viewer, and all of these things, and then try to erase these entries from these logs so that you would not find traces. So where do we find answers in this case? And we know that a lot of malware, a lot of attackers actually do that. So where do we find the information? We find it in network-based evidences. We find other ways of collecting host-based evidences. For example, we can use log servers like syslog or even SIEM software, so that we have a centralized server that collects all the logs from all of these different hosts. And remember, when we talk about hosts, think about servers most of the time, because your end user computer doesn't really provide a lot of information because it's not designed to provide services, while a server would generate thousands of times more log information that needs to be collected. So one of the best practices that we do is that we set up a log server that takes copy of all the logs, in kind of a live fashion, where if the attacker tries to delete log entries to hide their traces, we already have a copy of that log somewhere else. So this is just a general categorization of types of evidence based on where do we collect this evidence. Another way of categorizing forensic evidence is based on the volatility of the evidence. We know that we have volatile evidence and non-volatile evidence. So volatile evidence, basically evidence that is temporarily available, that might be deleted if we switch off the computer. Temporary information such as system time. Why is system time important? And we mentioned it twice until now. Why is it particularly important? Because all of your log entries are based on specific time of your computer. And it's very important that we capture that within the evidences, because sometimes we collect information from more than one place. And when each one of them has a different system clock or system time, we need to be able to match these things and synchronize them together to understand the proper flow of events that are taking place. So that's why system time is actually an important evidence. Network information is also considered volatile. Why? Because there is a good probability that if you restart your computer, maybe your IP address would change based on DHCP settings. And of course, number one at the top of the list of volatile evidence is memory contents. And memory contents can be extremely important in solving very complex problems. That's why one of the things that we have seen in the field is that we always tell people, if you feel that there is something wrong in your computer, like it might have been breached, you might have been a victim of malware or ransomware attack, do not turn off your computer. Do not restart the computer. Why is that? And this is something that happened, I have seen firsthand. One time we had a ransomware attack, and what we did is that when we got the call, we just told them, do not switch off the computer. We went there, we did some analysis, we figured out what family of ransomware the attackers were using, and we used a specific software that helped us in extracting the decryption keys from the memory of the computer, because the encryption keys that were used were actually still in RAM. So when you restart your computer, this will be erased and gone forever. So we had the opportunity to restore all of the data only because the person who detected the attack did not switch off the computer. So volatile evidence is, as we will see later on, is of extreme importance in forensic analysis. Non-volatile is easier to collect generally. Permanent data, such as data that is stored on hard disks or memory cards or registry settings, for example, that are stored on a hard disk or a USB drive. This data is non-volatile. We can, collect them later on. It's not as urgent as volatile evidence. So how does the evidence collection happen? The first step is evidence seizure, where we take the physical custody. And this is something that, it's kind of debatable in forensic analysis, is should we take physical custody of the device or not? Then we need to consider order of volatility, which we will talk about in a moment. Then we do some imaging and hashing, and we register and record the chain of custody. After the analysis, of course, we have to move on to secure evidence destruction, depending, of course, on the type of evidence, as we will see in a moment. Not all evidence requires destruction, but sometimes we do have to erase certain files. So let's go back to taking physical custody. This, as we said, it's kind of debatable, and people talk about it. People have different opinions about this. How do we acquire data? Now, in the past, people would simply unplug a machine and take it with them to perform the investigation. This is something that we stopped doing some time ago. Why did this have to change? First, because we need to collect the volatile evidence. We need to collect the contents of RAM. And if you switch your computer off and you bring it to me to investigate, that's not going to help a lot. One more thing, in many scenarios, as we will see in forensic investigation, if you switch off the computer, you're actually changing few things that are already there. Some settings, maybe the malware would delete itself, you know, things happen. So the best way to go about this is to have the computer in its current state. Just don't change anything. We don't want you to plug it from the power and bring it to us. We will come to you and we will try to acquire data in many different ways. So the acquisition of data must be performed transparently and reproducibly. Now let's stop at transparently. Why transparently? Because sometimes sometimes when we collect data, we actually damage this data. And I don't mean bad sectors or using, you know, poor quality USB drives. That's not the case. The problem is much bigger than this, because we know that files that are deleted on a hard disk are not actually deleted. They are just, their entries are removed from the file allocation table, which actually means that we can scan the hard disk and find these deleted files. Now, if for the sake of capturing the hard disk, I needed to install software on your computer to be able to extract data, this is a very poor choice in forensic analysis. Why? Because installing software is going to change the state of the system. So if I need to install something to be able to extract data, this is a very bad forensic analysis, because anything I install is going to overwrite some space that was marked as empty, but it might not be empty actually. So that's why we will see when we talk about making images of hard disks, it's extremely important that you do not edit anything. We switch on what we call write protect. Nothing should be written to the hard disk, because I need all the temporary files. And that's why we say don't switch off the computer, because when you switch off the computer, you actually delete your DNS cache, you delete your ARP cache, you delete your temporary files. And we need all of this as part of the investigation. So you should be prepared to report the precise methods. Sorry, we spoke about transparently. I would like to also stop at reproducibly, which emphasizes on the fact that it has to be reproducible. Whatever we do needs to be reproducible so that it would hold in the court of law. Because if it's not reproducible, it means that it might not be accepted at the court, because we are reaching conclusions that no one else can reach anymore, based on things that we have seen that no one can see anymore, which is not good in forensic analysis. So taking physical custody, as we said, the procedure is straightforward. And you can see we always start with documentation. Document preliminary information such as date and time. Take photographs of the computer if you need physical custody. Document the exact time of each step. And this is what we call the chain of custody. It's very important that for any evidence, you have a clear record that says who handled this evidence and at what time. When did you receive? If, for example, I took out a hard disk from an infected computer and I pass it on to someone else, then this needs to be recorded in the chain of custody. When did they receive it from me? They would sign for it. And when they deliver it to someone else for investigation, the other person will need to sign for it as well. Why is that important? Because we know that most of the time, the people who extract the data are not the same people who are going to do the investigation, not the same people who will do the analysis. Why is that? Because most of the time, the part of the team that extracts the data is the incident response team. And the part of team that does the analysis is the forensic analysis team. Most of the time in larger organizations, these are two different, completely different teams. Sometimes we bring in contractors from outside to do forensic analysis for us. So this means that we need proper chain of custody. That's why you can see we have 4 steps. 3 of them are about documentation. Collect all types of volatile, and we'll talk about volatile memory in a moment. So something very important that is called order of volatility. Order of volatility defines to us in which order should we collect volatile evidence. Order of volatility refers to the order in which you should collect the evidence. In general, you should collect evidence starting with the most volatile and moving to the least volatile. So what is the most volatile? Data in cache memory. Absolutely, data in cache memory, it can be captured in certain scenarios, including processor cache and hard drive cache. Now, if you take a look at hard drives that are used in servers, all of them, when you look at their specifications, you'll see that they have certain amount of cache, something like 30 megabytes or 16 megabytes or 10 megabytes, which is, we think that it's small, you know, it's a 2 terabyte hard disk with 30 megabyte only of cache, but this cache might include some very important information. So we start with cache memory even before RAM, and then we move on to data and RAM, including system and network processes. Paging file, if we have that, just a quick reminder of what paging file is. It's a file that Windows uses as an extension of your physical RAM. So when RAM gets close to being full, it creates a file on the hard disk that's called, most of the time, swap file in Linux systems. That would be considered like an extension of memory. So any process that is inactive for a certain time in RAM, it's moved from RAM to that paging file. So this means that the paging file is as important as the contents of RAM. Next on the list is data stored on local disk drives. That would be getting hard disk images. Then logs stored on remote systems. As we said, when we have log servers, it's a good idea to take a copy of these logs just to take a look at what happened in terms of, at the network plane, not at the host plane. And then archive media. If we have backups, for example, we might have backup of the system before infection. That might be useful so that we can compare the 2 systems and see what's the difference. In other scenarios, that can be also important because sometimes, and this has happened, sometimes we detect a breach and we find out that the malware that actually caused the breach was implanted in our systems 3 months ago or 4 months ago. And there are, scary statistics about how long it takes for businesses to find the incident, to find out that they have been breached. The global average is around 3 months. Imagine a company that has been breached for 3 months until they know that they have been breached. So archive media can also be useful as part of the evidence. So we collected the contents of RAM. Of course, there is special software to do that. We'll talk a little bit about the tools, tools like a Volatility framework. Of course, if the machine was actually a virtual machine, and in this case, we have a lot of this happening right now because a lot of organizations are relying more and more on virtualization and relying on cloud infrastructure. So this means that it would be much easier to get images, or whether RAM image or hard disk image. So disk imaging is basically creating a file that contains contents and structure of data storage device. So I see a question in the chat. What about a virtual environment is doing a snapshot of? Yes, it depends, of course, on what type of virtualization software, but I know that VMware software, for example, VMware Workstation, if you create a snapshot, it would automatically capture the content of RAM and put it in the snapshot. There will be a file that's called .vmem that's available within the snapshot that would hold, sorry, all the contents of RAM. That's a good question, Mark. Thank you. Now, just keep in mind that imaging is not copying the contents of the hard disk. It's not file copying. Imaging basically means that we read every sector of the hard disk and we take that content and place it into the image file. So this means that all the files that are deleted will also be captured. All the files that have been corrupted will also be captured. All the sectors that have errors in the hard disk, all of this will be captured. And that's what we mean by disk imaging. It's not copying the files, it's taking a full image. It's like a full scan of the whole hard disk and creating one file that holds the whole hard disk. And of course, the software, it depends. You can create multiple, you can split it if it's very large, like server hard disk that's like 8 terabytes or 10 terabytes. You can split it into multiple files. But the idea is that the image is very different from copying files. It's a complete image of every bit on the hard disk. Now, after we take these images, it's important to do forensic hashing. It's extremely important, actually. So just a quick reminder of what hashing is. Hashing is a mathematical process that is irreversible. Sometimes you find people who call it irreversible encryption. Basically, hashing means generating something like a signature of a file. We pass all of the data into a hashing algorithm, which is an irreversible mathematical function that would generate a string of bits that represents the hash. If one bit in the input changes, the resulting hash is going to be different. So we use that as a way of maintaining integrity of the files that we generate. Whenever we generate an image file or even a memory dump file, we generate a hash for that file and we place it with it in the same folder. Why is that? Because anyone who remember, we said that it might be a different team that's capturing the data and the one that's doing the analysis. So after you capture the data, you have to generate hash. This hash will be used as the signature of the file to assure its integrity. When you send it to the analysis team will regenerate the hash and compare the resulting hash with the received hash. If they are matching, it means that the file has not been corrupted during the copy process. If it is different, it means that the file is corrupted. I have to go back and get a fresh image. So this applies to almost all digital evidences that you get. Not only hard disk image, not only memory images, anything that you get from the system, all of the data that you extract from a system, they need to be hashed to assure their integrity. So a question from Cyril. So when will you perform the initial hash? As soon as you, exactly. As soon as you extract the data. And we keep in mind that because of volatility issues and because of hard disk issues, extraction of data needs to be a completely passive process. Completely passive, meaning that we don't want to edit anything on the hard disk. I just want the whole thing with its temporary files, with everything. So whenever I generate this initial image, I create the hash immediately. And later on, whenever we move the evidence to someone else, we need to regenerate the hash just to make sure that it's matching to the original captured information. Thank you for the question. That's a very good question. So an important rule of digital forensic investigation is that you should never work on the original data. Working on the original data is usually called live forensics, which is something that you need to be very, very careful with because it will be altering the system state. So the important rule is that we should not work on the original data. Every time you created an image, you generated the hash of the image, make a copy of that file so that you make sure that if something goes wrong in the image that you're examining, you have a backup image. So it's not the original, it's not the image that we work on directly, it's a copy of that image that we work on, just in case a problem happens, then we will need to reuse a new version of that image, or a fresh copy, I mean, of that image. What sort of encryption so you use for hashing? I think the most commonly used now is SHA-256. It generates a 256-bit string. Previously, we used to use MD5, but MD5 had collision issues. So currently, most of the time we use SHA-256. That you can find, it's built into Windows, as we will see in the demo. It's built into Windows. Courts require that you work this way unless demonstratively impossible. So this just makes sure that you don't work on live data, work on the images, a copy of the images. So these are multiple tools that can be used to create images and hashes. DD, which is a tool that is built into Linux systems. And then there is a newer version of it, DCFLDD. There is DC3DD, that all of these images, all of these tools can be used to create images of full hard disks. On Windows, the most popular one is Ftk Imager. Ftk is a framework of just big group of tools in forensic analysis. Ftk Imager is a free part of that toolbox, but the remainder of the tools are paid tools. So Ftk Imager is software made by Access Data that can image a hard disk. It can image a memory as well. And because it's a toolbox that's designed for forensic analysis, so it creates reports for you. It simplifies the whole process. So when you capture the hard disk, it asks you for information, like, for example, what evidence is this, what version, it will automatically store the date and time and all of these things so that it would make your life as forensic investigator much easier. So memory acquisition, capturing, sometimes you call it dumping memory, sampling memory, involves copying the content of volatile memory to non-volatile storage. This is arguably one of the most important ones. One of the most important parts of the data that we capture from the system. This is a general acquisition overview. If it is a virtual machine, then the capturing memory is super easy. You don't need to install any software. You don't need to add anything. Just create a snapshot or pause. It will automatically store a copy of the RAM of the virtual machine. Of course, when we say virtual machine, this means that this applies to cloud infrastructure as well. If it's not a virtual machine, is it running or not? If it's not running, then it's not the end of the world if it's not running, but generally you'll have to look deeper into hibernation files, paging files, or so. If it is running, do you have administrator access? If you do, you can use software. You can pick what type of software you want to use. If you don't have administrator access, then you might need some hardware to be installed on the device to be able to capture it. Of course, this hardware is not hot swappable. You cannot install new hardware while the computer is running. This is something that usually is created and built into the server system so that you can use it if needed. So if you don't have the hardware tools to capture memory, you cannot install it after the incident. We already talked a little bit about chain of custody, and we said how important it is to have a clear record of everything that's that's collected all the evidences, how it is stored, how it is packaged, because that would be presented to the court whenever you present any evidence to the court. You can see what needs to be included, when it was taken, what is the item, who has seized the item, who acquired the item after its seizure, and so on. All of this information needs to be recorded and logged properly. After the fact, we might need to do evidence destruction after the analysis, depending on a particular organization, risk appetite. Sometimes we need to keep it because it might come up a few years later, for example, that we need to provide a record of all the incidents that took place a few years back. It really depends on the policy of the organization, depends on the type of business that the organization is doing, because the type of business might pull certain requirements. So if you're handling credit card information, you need to follow PCI DSS regulations. If you're working in an organization that is, for example, handling health data, you need to follow GDPR and so on. So the idea is that it's very flexible on how you want to create the policy and how you want to follow this policy for evidence destruction. Of course, destruction is highly connected to evidence retention as well. In evidence retention, we think about things like prosecution. What is our data retention policy? For example, some organizations, their data retention policy says that certain high priority documents need to be held forever. They should be available always. Certain things can be discarded after 5 years or 10 years or 20 years. Well, it really depends on the organization and what kind of policy you have and what kind of budget you have to retain all of this evidence. Reporting, of course, is basically the conclusion of the forensic process, and we know that the report should have certain features in it. First, it has to adhere to proper spelling, grammar, and style. It has to be accurate. And when we say accurate, it means that it has to be fully detailed and everything should be double-checked for correctness. When you use a specific tool to capture memory, you record that. When you use a specific tool to capture hard disk content, you specify that. Any command that you run on the system must be recorded, and at which time did you issue that. So we have a question from Faizan. How does the data retention policy change when dealing with third-party involvement? That would be mainly in collaboration with the third party, because part of our privacy policy, we should state to our third party what kind of information are we holding, why are we holding it, how are we going to use it, who are we going to share it with, and also how long are we going to retain it. So it's usually an agreement with the third party on specific types of information. Another question, how best can one handle data recovery from an encrypted hard disk? Wow. Yeah, that's a tough question. Actually, hard disks that are encrypted, if you don't have the decryption key, especially hard disks that are encrypted with newer technologies like AES, for example, it's not going to happen. You will not be able to decrypt the data. But generally, if data is encrypted using things like BitLocker, for example, BitLocker uses TPM technology, which is a chip on the motherboard of the computer that holds what we call the hardware root of trust, holds the keys that are used to encrypt the keys that are used to encrypt the hard disk. And that's how BitLocker works, basically. So the first rule to handle this kind of case, if this is the case, if it's not ransomware, the first rule to handle this case is that do not remove the hard disk out of the computer, because the hard disk needs the TPM module on the motherboard to be able to decrypt the data. I know that this is not a conclusive answer for you, but I'm just giving you some possible ways to go. So the report definitely should have an executive summary, 1 or 2 paragraphs, high-level overview that contains just simple information about the incident. Now we need to think about how do we link all of this to protecting the organization. One of the most important outputs of a forensic investigation is finding the root cause. And that would help in figuring out what needs to be done to prevent this from happening again. And this can be one of the most important outcomes of a forensic investigation. The investigation can have some recommendations about upgrading, updating, or patching certain systems, introducing new security controls, maybe suggest new firewalls, new intrusion detection systems. Sometimes if patches are not available, so one might ask, when would patches be not available? Sometimes we have, especially in manufacturing IoT, SCADA systems, for example, most of the time, manufacturers of these devices, they do not care a lot about security. So most of the time, they don't patch the system. So we need to do something else, like isolating the system, disconnecting it from the internet, or things like that. That would be part of the recommendation. So let me move on to a very quick demo. I'm very cognizant of the time that we have. So I'm gonna switch on to virtual machine. So this virtual machine has malware. Just to double check before I start messing up with the computer, I want to make sure that it's disconnected from the internet. Then I'm going to turn off Windows Defender so that it doesn't delete the malware before I get to look at it. And what we will do now is part of forensic analysis that is looking at static malware analysis. So we're just going to take a very brief look at the malware. So now it's switched off. Let me decrypt my malware. Okay, let me also start another virtual machine that we will need to use in a moment. So these 3 folders contain evidences that were collected from an infected computer. Okay. Just a quick look at these files that contain malware, DLL file that contains malware, an executable file somewhere here, yeah, that also contains, and it's not a regular malware, it's actually ransomware. So what is one of the first steps that we will do? Let me show you. There is a very famous website that can be helpful in static analysis for evidences that we collect. A website called VirusTotal. I'm sure you've heard of it. VirusTotal. So what we will do is that we will go to the Windows machine and we will generate hashes from the PowerShell. So it's warning me that there is no virus protection. I'm going to move on to the desktop to evidences and then take a look. Let's take a look at the executable file, which is the ransomware. cd craig.elder. Sorry, that's misspelling on my end. Elder cd app data. Take note that I'm using PowerShell. I'm not using the regular command line. And then it's a bit of a maze, the directories here. cd temp directory, and now we have the file. So what I'm going to do is I'm going to generate the hash. Get file hash, and the hash for the file tzq.exe. Okay, this is the SHA-256 hash. I'm going to copy it. And of course, because this computer now is dealing with malware, I'm not going to connect it to the internet. I'm going to use another virtual machine, go to VirusTotal, search, and then I'm going to paste the digital signature or the hash. Now, looking at that, you can see clearly that all of the different detection mechanisms, different detection software is saying that this is unsafe. This is, you can see some CLAM AV, which is famous. It's weird that it says undetected. Malwarebytes does not detect this, which is a really sad thing. Community tests, you can look at this and it says this is the family of the malware. Cobalt Strike, that name, domains that it contacts, the hosts that it would contact, IP addresses of the computers that it will try to connect to, all the different libraries, and I will come back to this to take a deeper look at it. So this gives me a lot of analysis. And this is part of the information that we can have. Now, we can do something else with this software called PEID that looks into the portable executable file. So if we examine this file, it has some information. It says that the file was packaged using Microsoft Visual C++, version 8. It has multiple sections within the portable executable format that contains text and data. Let's take a look at the subsystem. We have things like the magic number that says that this is a file that was designed to run on Windows. Magic numbers are different between Windows. Yeah, there is a question from Serial. Yes, it might be useful to check. And remember, we're not talking about all of your files. We're talking about, for example, files that you have received from an email. Generate a hash, go to VirusTotal and see what it says about it before you run it. Sorry, so going back to this, one last piece to show you. Something that's very important is called the import table. The import table shows what DLL files, what dynamic link libraries that this malware calls. Why are these important? Because it gives you a very good idea on what the malware is going to try to do. So something like, for example, this COM control and looking at all the specific APIs that are being called, you can see that this file is going to try to connect to the internet. So it's not only malware that's going to be locally running on your computer, it's going to contact the kernel, probably to you can see it's calling a lot of stuff from the kernel. It's going to do some edits to the registry. As we can see from the processes that are shown here, it's going to add some values to the registry. It's going to create replicas of the process that's being done. And there is, of course, other ways of doing analysis. I'm not going to go into the details, but it's just a general idea on small tools that are available that can help you in getting some information. So let me go quickly back to the PowerPoint slides. I believe I'm almost done. So does anyone have any questions? I know that this has been a bit of a brief summary. Anis, go ahead.
Mr. M. Alani, thank you. Thank you for an informative session within an excellent demo, as the practical demo always stands up on the theory. So thank you. So now we can have our questions. Anyone who has questions, so can raise the hands, and please.
We have one from Anish and the other from Shahzeb Abdul.
Yeah, definitely.
Anis, unmute your microphone.
Hi, my name is Anis Patel, student of UOB. Basically, my question is like, if we consider a scenario for transmitting. So basically, if we consider a scenario for transmitting a data over a network, so which one is better, whether we use an encryption or whether we use SHA? Because if we consider SHA, then it's an irreversible process. whereas we consider encryption, then it's a reversible process. So if we put it in terms like, as a part of security, as well as a part of time calculation. So which one is better, encryption or the SHA or the hashing?
Absolutely encryption. If you need to reverse the process, then SHA and other hashing algorithms, they're unreversible. They're mathematically designed to be unreversible. So my bet would be on AES encryption. That would be with a key size of 128 bits or 256 bits. That would be secure, or even RSA encryption, depends on whatever you want to use.
All right, thank you.
And the next one is Cyril.
Hi, Mohammed. How would we as young graduates get into forensics, and what vendor qualifications are starting would you recommend?
Well, I think that that's a very good question. The forensic investigation starts with learning about all the tools that are available. So I would recommend looking into books. I can share with Dr. Celestine some list of recommended books that I can share with you. I think on my next slide there is, oh, there isn't. Usually I put a list of tools at the end that for you to look at, but I probably forgot to do that. So yeah, I can share with you a list of a couple of books that would really help how to set up your virtualized lab on your computer to start working for forensic analysis. In terms of vendor, I think that Ftk would be the top priority, the most used software tool set. So I would suggest to look into Ftk and see if they have any certifications.
Would Security Plus be good in this regard?
Well, Security Plus gives you a really good jump start in security in general. It doesn't really cover forensics that much. Probably Cybersecurity Analyst Plus has a little bit more, not too much about forensics.
Okay, thank you.
No problem.
And the next one is Faizan Muhammad.
Hi. I wanted to ask about like a personal experience about you starting security for forensics, and exactly how you've seen technology grow and what's your experience in the way that technology is evolving, especially in security forensics.
I can tell you a personal experience. When one time a place I worked in was hit with ransomware, which was not a pleasant place that you wanted to be in. But we were not at our best in terms of the security posture. We were extremely lucky because we did a full system backup one day before the attack. And this was out of pure luck because our normal backup system was not being followed carefully, and we had certain loopholes, and then we ended up being hit with the ransomware. But luckily enough, we had a backup one day earlier, so we lost data of one day only. We managed to bring the system back up within like 4 hours, and that was an academic institution, so it was a matter of life and death to us to get the system back on as early as possible. I think that a lot has happened, but many of the non-commercial tools did not really follow up on that. That's why you see a lot of the free tools that are available. Most of them are not compatible with Windows 10. Most of them are not compatible with the recent versions of Linux. But the paid versions, unfortunately, the paid versions are trying to keep up with what's going on.
Now we have Windows 11.
And now Windows 11, which makes it even more complex because it's a very different. It has a very different way on handling applications and private areas in memory and in hard disk, and it's a game changer actually. Windows 11 in terms of security.
And the next one is Shahzeb Khan.
Hi. I would like to ask, I have two questions basically. One is basically VirtualBox and VMware. I mean, I have seen people that some prefer to use VMware, but some say that VirtualBox is better. But both are used for virtualization. But what is the difference?
Well, I think from my personal experience, I've used both. I settled eventually on VMware. I felt that VMware is more reliable in terms of how virtualization is handled and how the amount of isolation. I think VirtualBox is a very good product, but I don't see many differences. I think one of the advances of VMware is that VMware is highly connected to their large production. VMware is a huge corporation and they have large scale virtualization software that is used in clouds and used in many industrial applications. So VMware, I think, remains the work of a very hardworking group of researchers and developers. So I think generally, to me personally, VMware I think is better.
I think, but it's not free again now.
It's not free. No, it's not.
That's why the students are using the VirtualBox.
Yeah, and VirtualBox is not bad. I'm not saying it's bad. I'm just saying that because I have, you have seen on my desk, I have like 20 virtual machines that sometimes I run 5 or 6 of them at the same time. Sometimes I need to do a lot of virtual networking between them to set up specialized networks. And VMware has a very good virtual network editor that enables you to create different segments of network virtually, which is not available in VMware.
Okay, the last question, if for example, some of us are really, interested in the field. I mean, if you see in media, I don't think hackers or the security experts are portrayed in the right way. I mean, you see hacker hacking into a grid in like 10 minutes, 15 minutes. But from that, we get a wrong idea, like hacking is this easy and like that. But if we want to get into this like field, like in the blue team, purple team, red team, or like they become expert in one domain, how do we start and how do we go about it, increasing our skill set, our knowledge, and apply those in the real world to solve real world problems and to give our services to real organizations?
This is an excellent question. And I could talk about this for hours, honestly, but just very quickly, because I'm aware that we run out of time. Generally, I would say that you have to be very patient and you have to have a really strong appetite to learn because there is a lot to learn, so much. I think Security Plus is a good start to put you on the right direction. But later on, if you're interested in red teaming, then you would look into things like websites like Try Hack Me, Hack the Box, and Pen Tester Labs, also very good. To me personally, I think Try Hack Me is the best for someone who's just starting up. It has a lot of educational tracks, and the subscription is not very expensive. I think it's like $10 a month to have full access to everything they have, which means that for $30, you can have 3 months of full learning on exploitation and learning to use the tools. I think that it's a very good start for someone who wants to work in penetration testing.
Okay, thank you.
Thank you.
Thank you very much.
Anyone else who has a question?
Hand over to him.
If not, then I have questions.
Yeah, sure, go ahead.
So my first question is about the identity. Like you were talking about to present the results in the court as a reference. So main question is, like, I was having a look over conference where the world leaders were contributing, and there was a discussion and later on that US was saying that Russia has introduced in their elections and so on. So definitely there was a question for the Putin that you have intruded into the US election. So what the Putin said that that's not a question, how we have introduced. So the question was like the IP references, and they are the reference. You are saying that they are the references that Russia has done that. So what the Putin said. Putin said it's not a uh, big deal to work. Like he said that it's a weak reference. Like when I am going to intrude anywhere, so then I can definitely mask, I can change the IP. Like exactly, now my team will send a SMS on your phone and it will show like it you have received from your kid. So that was the answer. So he said that these are the weak references. So so how what are the main you can say results which can be presented into the course as a reference, like any intruder who is going to intrude any system, so he definitely masks his identities, he use the multiple proxies and so on, and then the later on definitely he can remove the references and footprints from the servers and so on from the network as well. But that's the second stage. But the first stage is like any intruder who is professional and going to intrude into any system, he will not show his identity. He will mask definitely, and he will use the multiple proxies, complex proxies, and what are the procedures to identify it, like from where the intruder.
I understand. I think that this is basically called attack attribution.
Yeah.
And this is one of the most complex things in cybersecurity is after finding out there is an attack and after finding out what the attack does, attributing the attack to a specific person or group is one of the most complex things. And I can say that absolutely no one uses IP addresses anymore to attribute these attacks. People look into different things, like, for example, the way in which the malware code is written. And if it is similar to some other previous known work of that particular group. I think talking about the APTs or advanced persistent threats that operate on a country level is not an easy thing to attribute to. And you know, we need to have a lot of evidences that would look at the type of how the code is written, what kind of libraries they use, what kind of techniques they use. And that usually takes months and months of research just to find out who created, for example, this particular malware. It's not easy.
Yeah, definitely. And the other question is, like, I am from the banking fintech domain, so we were using different softwares like you were talking about, like the SIEM and then the WAFs and then the multiple firewalls and so on. And problem we face, because when you are public facing organization, then definitely you have a larger public traffic and there will be emails and definitely the contacts and the calls coming on. What the softwares do, they just block the user and intimate the administrators. So administrators wait and definitely don't unblock those users, like the emails. Sometimes the very important emails are lost, and the revenue loss comes to the organization. That's the main thing. Is there any AI in doing some work, like you can say AI based organization who is just predicting the intruders or the attacks on some trained models, and not just blocking the every you can say um, any doubtful, like minimal doubtful traffic?
Absolutely. Intrusion detection and prevention was one of the earliest areas of cybersecurity where machine learning has been adopted. And to me personally, I've been working a lot in the past year on solutions to detect attacks and different types of attacks, intrusions in IoT and in computer networks to detect these attacks. I think that the future is in machine learning. However, we're not there yet. Machine learning systems that we're developing now are mostly academic and research focused, and most of them are not deployable in real life. And we need to shift the focus into systems that can actually be used in real life, systems that are not focused on research.
And I have done some research on that topic, and some organizations are doing some work, but those are not trustable. and specifically in the fintech and in the banking domain, because no one from the where the money matters, no one does give the permissions to use the data. And for definitely to predict the model, to train the model, the data is very necessary, and the hop data specifically, and the organizations are not allowing it. That's the main problem. Thank you, Muhammad Alani, for a very informative session. So that was a very informative session. So now I will hand over to Miss Ancha to present the trophy to our honorable guest.
Thank you, Professor Alani. It was really informative, and I am seeing that the data analytics students are actually going to divert their area to cyber and forensic analysis. So it's great to see that they are actually streamlining their interest, and I hope to see their final projects in forensic analysis. So thank you very much. And
thank you very much. I appreciate it. Thank you.
Yeah.
Thank you. Thank you.
Thank you very much. Yeah.
Okay.
Thank you. Appreciate it.
Yeah.
Dr. Celestine, thank you very much for the invitation. This has been a pleasure to me. And yeah, I really enjoyed this session.
Thank you so much for coming. We appreciate. And every of the guests, remember, we still have another one tomorrow. Thank you very much. And
thank you.
Good night, everybody.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you.
Thank you very much.
Thank you very much.